Good morning. My name is Ms. Booth, and I wanted to go through a couple of math strategies that we are using in class and give you an example, so that way when your child is working on homework or working on just practice for their morning art quizzes, you know what they're doing. So this image is on the back of the newsletter that I sent home with your kids today. I want to try to start doing that once a week with our math intervention kids, especially because I know that the strategies that we're using for math are entirely different than what you and I probably used when we were in school. So on this top left section, you'll see what is labeled as a hundreds chart, and we use these hundreds charts, and it's literally just a chart with numbers from 1 to 100 on it, but we use it for patterning and skip counting and being able to add groups of numbers and things like that. This other chart on the top right is a place value chart. It just helps to organize our numbers by their place value. So if you have the number 43, for example, you would write it just like this, and you can see that the 3 is in the ones place. So that means if you were to build it with place value blocks, you would have the 10, 20, 30, 40, and then you would have 1, 2, 3 little blocks. And so the 4 right here shows that you have 4 groups of 10. So if these were actual place value blocks, they would be more rectangular with the teeny tiny 10 blocks inside of it. Over here on the bottom left, I X'd this out right here just temporarily. Our third graders are learning multiplication right now, but they have not started the division relationship yet. And so I'm not going to introduce this to our students in intervention until they've introduced it in their math classrooms. But this will open back up whenever I send another newsletter home in just a couple of months. But over here, the addition and subtraction fact-family relationship is really, really important. We teach our kids to look at it kind of like a triangle, where the oldest member of the family or the largest member of the family lives on top, and then the smaller ones live on the bottom like this. And so this works for addition and subtraction, and it will also eventually work for multiplication and division. But this just shows, if you look right here at these 4 equations, that all 4 equations, whether you're adding or subtracting, only include these 3 numbers. And so if they're used to those patterns, that will really help the students to recognize errors or recognize patterns in trying to solve those problems. So subtracting across zeros is just a method that we use here at Northside, but it's also another one that's common just with current strategies of solving these days. And it kind of just helps students to stay a little bit neater and more organized. So I'm going to show some examples of that in just a minute. So if we go to this specifically, the hundreds chart, one particular pattern I was working with students on the other day is if you were adding groups of 10. So let's say that we were adding 44 plus 10. What I was asking the students to do was go on to the hundreds charts, and we have it tucked inside a page protector here at Northside, so that way they can use dry erase markers and physically write on top of their hundreds chart and just erase and reuse it. So they would find the number 44, and I ask them to circle it. And so we look at the numbers, and we can see that when you're moving up, the numbers are increasing. When you're moving, I'm sorry, that was completely backwards. When you're moving up, I apologize, the numbers are decreasing. When you're moving down on the hundreds chart, your numbers are increasing. And so when you're adding 10, you can see that if you're skipping from 1 to 11, that's plus 10, plus 10, plus 10, plus 10. And so when they're adding one group of 10 right here, they take the 44 and they move down 1. So they can see that 44 plus 10 is 54. So that is just a shortcut and a visual for students to be able to see to add 10. But you can also do it when adding groups of 10. So let's stick with 44 again. Whenever I'm giving example problems like this, I really like to start with the same initial number just for patterning's sake. And let's say it's plus 30. So that means you're going to move down 3 different times because it's groups of 10. We don't start counting until we move. So we'll circle 44, and then I always dictate it out loud. Move count 10, move count 20, move count 30, and they can see that their answer is 74. Okay. If we go on to, and that works also for subtraction, you would just go backwards. So I'll switch colors right here. If I were to do 44 minus 30, I would circle 44. And instead of going down to increase, I would go up to decrease. So minus 10, 20, 30, and your answer is 14. When we go to fact families, I was showing y'all before that they just go together. And so, for example, if I were to give you, you can even go larger, like 25, 12, and 13. I always encourage the kids to check it. And so for the add-ins, the parts that are being added, they would stack 12 plus 13. And when they're looking at it this way, I try to make sure that they see that it's organized with tens and ones. So they start with the ones place. You may see every now and then the kids boxing the ones place in green, boxing the tens place in red, and I teach that to them in terms of red light, green light, because green means go and red means stop. And so they're going to do the green side first. So 2 plus 3 is 5, and then 1 plus 1 is 2, and so your total is 25, which you can see up here was our total. So we see that we have the 12 here, 13 here, and 25 here. And that works also with what we call the inverse relationship. The inverse is going to be the opposite. And so when you're subtracting, you start with that total, which is 25. And then you can use either one of these parts to subtract. So the goal is to always have one of these three numbers as your answer. So again, we start in the ones place. So 5 minus 2 is 3. And then we end in the tens place. 2 minus 1 is 1, which is perfect because we have 13 right here. The place value chart is something that we use for organizing. A lot of times when you see a multi-digit equation, let's say 321 plus 132, when the students, we always teach them to stack and solve it. And so when it's presented like this horizontally, they are not able to solve it, to regroup. And so we'll come down here and we'll stack it up. So you should write it 321, and then your numbers should align exactly. But let's change this actually to 100 or to 32. So 321 plus 32. A lot of times when they're taking this 2-digit number to add to the 3-digit number, they misalign it. And so it would be set up right here instead of all the way over into the ones place. And so the reason why we use the place value chart to start with to teach the kids how to organize it is they can use each of these boxes in order to set it up. And so if you're putting this exact equation right here, you would start with the top one, the 3-digit number 321, and then put 32 underneath it. So you'd see that there is not anything in the hundreds place right here. And so from there you add the plus sign, and I always call this the equals line. So from here, just like we did earlier, we can, I always do green, yellow, red when it's 3-digit, just to still remind them that green means go, you want to start with that number or that place value. So 1 plus 2 is 3, 2 plus 3 is 5, and then when there's nothing here, I teach them to bring down the 3. Another way that we teach the kids to check their answer is to do the inverse. The inverse is when you, kind of like the fact family that we talked about a minute ago, you turn it around. So I always teach the kids that it's called bottoms up, kind of like when a duck goes underwater in order to find food. You take the bottom number and then place it on the top. And then you're going to take the middle number, 32, and place it here. And then you're going to set it up as an equation again, but instead of adding, you want to do the opposite. So inverse means opposite, and so we put a subtraction sign right here. So when we go through and solve it, 3 minus 2 is 1, 5 minus 3 is 2. Again, we're going to bring down the 3. We see that it's 321, which matches our original top number. And so you can see when I call it bottoms up, the bottom number matches the top number, middle number matches the middle number, and then this top number matches that bottom number. So they are exact matches, just in the opposite order. Another example with regrouping. So if the problem was presented up here, 592 plus 739. Lots of regrouping. I'm going to go ahead and set it up in the place value chart. So we've got 592, 739, and we're adding. We've done a couple like this week, and it confused a couple of students because we end up coming to the thousands place, and so I'm going to show you how we do it here. So 2 plus 9 is 11. I always teach them that you're only allowed to write one number at a time in each of these boxes, and so you can't write both ones in that box. So we write down the first one, and we bring the other one on top. And I always circle it just to make sure that they see it. And then I start from the top and go down. So 1 plus 9 is 10, plus 3 is 13. We can't write 13 right here because it's 2 digits. So we bring the 1, slice the 3 right here, and carry the 1 again. This is another step that often gets missed because there's already the 1 right here. And so students think, well, I've already done that. But we have to make sure to do it again because the 13 can't just get rid of the 1. So again, start from the top. 1 plus 5 is 6, plus 7 is 13. We don't want to write 13 here exactly, so we're going to write the 3 and then the 1. And that way, when you're using it with this place value chart, you can see that that comma is already there. And so your total is 1,331. I'm going to show you how to do the inverse with that place value chart. So I'm going to copy this over really quickly. 739, 592. Okay, so in order to check this math to make sure that it was correct, we're going to go bottoms up. So we're taking the whole, which is called the sum when you're adding, and write it here in the place value chart. So 1,331. We're then going to the middle number, which is 739. It's one of our add-ins. When you're subtracting, it changes to the subtrahend. The subtrahend is the first number. The minuend that you are subtracting is the next one. So, all right. So 739, and then we're going to subtract instead of add because we are doing the opposite. So when you come right here, you start in the ones place. We are not able to do 1 minus 9. So on the newsletter, I have a couple of tips and tricks, and so one of them says more on the floor. That shows that that bottom number is more on the floor. Go next door and get 10 more. So we go next door, we go over here to the 3. So I'm going to cross out the 3. It becomes the digit smaller, so it's going to become a 2. And instead of this being a 1 right here, we want to add another 10 to it because we're bringing that over. So it becomes 10 plus this 1, which is 11. So I always cross that out so we don't get it confused. So 11 minus 9 is 2. Then we're going to come over here to the tens place, and we see that we're left with 2 minus 3, which we cannot do. And so we have more on the floor, so we're going to go next door and get 10 more again. So that becomes a 2, and we're going to add that 10 right here to the front. So that becomes a 12. So 12 minus 3 is 9. We come over to the hundreds place. We can't do 2 minus 7 because there's more on the floor, so we're going to go next door and get 10 more. So that becomes 0. This becomes 12, which I know is the same as looking at it that way, but with our young students, we go ahead and show this process of crossing it out because that's what they're used to in learning. So 12 minus 7 is 5, and then I always go through and check. We want your difference, which is the answer to subtraction, 592, to match the top 592. 739, 739, and then 1,331 matches here. So this is a very big example of how we use the place value chart to help organize. So you really just want to make sure that when kids are writing their equations that they are lined up exactly. If they don't have a place value chart like this, I show them that they can make one. Usually it's just 3-digit numbers, but I always label it hundreds, tens, ones, and then from there they can set it up accordingly. Okay. Our very last thing is subtracting across zeros. This gets messy, and that's why we practice in class with this chart. Because if you're looking at the number, let's say 500 minus 94, we know that we start in the ones place. Here, I'll do it with our color code. 0 minus 4 we cannot do because more on the floor, so we have to go next door, but there's nothing to get here. And so we could go next door again, make that a 4, make this a 10, cross it out, make it a 9, 10, but that is a lot, and it's messy, and it's confusing. So what we've been teaching the students is, oops, I erased my equation. What we've been teaching the students is, let's see if I can remember my original, 500 minus 94. If there is more on the floor here, and you notice that there's nothing when you go next door, then we're gonna go here all together and see this as a 50 and box it and cross it. So then you're gonna go one less. Instead of 50 tens, which is 500, we're going to have 49 tens and then bring 10 over here. So then we have 10 minus 4 is 6, 9 minus 9 is 0, 4 minus nothing here, so 4 minus 0 is 4. Okay, and then to check that, you can come over here and do the inverse 406 and then add, because it's opposite, plus 94. And again, I always ask the kids, what do we want our answer to be? We want it to be 500. So we'll check. 6 plus 4 is 10, carry my 1. This is important why it's all lined up also. 1 plus 0 is 1, plus 9 is 10, carry the 1. 1 plus 4 is 5. Okay, so one more example, subtracting across zeros. It works like this only when you're having to go next door and there's nothing there. And so for example, if we're looking at, let's do 700 minus 362. So there's more on the floor. If we go next door, there's nothing there. So we're going to box our 70. It becomes 69. This becomes 10. 10 minus 2 is 8. We look right here because it's no longer a 0. 9 minus 6 is 3. And then this isn't a 7 anymore. We're looking at 6 minus 3 is 3.